Does anyone know if Connor's gonna be able to meet with us ever again? Or do we need to like change things?
He hasn't responded to those emails that we've been sending out, so I think he may not be in the class anymore.
He said something earlier in the chat, maybe?
I
Or
think he
something
got
like,
a new job and something
yeah.
like that. Um,
Yeah, he said, I'm starting a new job tomorrow, so I'm not going to make it to the meeting. And I don't know what my schedule will be, but we will see. So I guess we just have to
Oh,
wait to see if he lets us know. Oh, well,
well,
okay. Okay. So it says, which hypothesis involves equality?
mm, I think it's the null hypothesis.
That's what I was thinking too. Hold on, let me get the book open too.
yeah, that's what I'm trying to do.
Yeah, I think it is a null hypothesis.
It's the null.
Pretty sure. Okay, cool. I was pretty sure it was. I just wanted to make sure I wasn't thinking of it wrong.
Yeah.
Yeah.
The book confirms.
Oh, okay, yeah. No hypothesis and equals. Oh, okay, I get it. Yeah. Okay, cool. Okay, so number 4 is asking, when you're computing the p-value, which hypothesis do you assume to be true?
Null again?
Yeah, I think so. I don't know.
Yeah, 'cause I think you're assuming. Yeah, because you're assuming that the null hypothesis is true, even
Yep.
though you might have an alternative hypothesis. Pretty sure.
Yeah,
Yeah.
that's what the book says as well.
Cool. Question 5 says, suppose this null hypothesis. Okay, so this is asking for alternative hypothesis for a two-tailed test. And that would mean that it's just either less than or greater than the null hypothesis.
Yeah. The third one.
So I think it's the not equals to 1.
Yeah, it's the not equal to. It's the
Cool.
we'll take the third one, the C.
Yeah,
Yeah.
mu equals with a slash and then 10.
Yeah.
Cool. And then number 6 is asking for a left-tailed test, which would mean that it would be less than the mu, right? Or
Yeah.
the mu 1.
Yeah, it's the mouse turning to the right.
Right. Less than.
So it's the first one in essence.
Yes.
Yeah.
And then it does the right-tailed, which is the other one.
Yeah.
I always think of it as Pac-Man. So if it's eating it,
Yeah.
Okay. Oh, this is a good letter. Okay, what is the relationship? Which relationship would result in failing to reject the null hypothesis? Uh, so I'm thinking it's going to be this one. P-value is less than the level of significance, I think.
So it's actually so what the book says is that if the p-value is greater than the little a sign,
Mm-hmm.
we fail to reject the null hypothesis.
Oh,
Yeah.
if P-value is greater than it? Oh,
Yeah.
Great. Yeah.
gotcha. Cool. So that means the opposite would be true if it says you're
Yeah.
rejecting the
Let's.
null hypothesis.
Yeah.
That would be. Yeah.
Okay, so now we're on to question 10.
Yeah.
Oh, okay. So we have to figure out the alternative hypothesis. Which one do you guys think it is?
Um,
Mm.
I think it's the greater
Oh.
than one.
Yeah. I was thinking. C.
Yeah. Because
That's what
it
it looks
says
like.
they think that it's actually higher, so the null hypothesis would be that it's equal to 1500. Alternate
Yeah.
hypothesis would be that it's greater than that. Oh, and then that means we know that this one. So 11A, I think, equal to 1500.
Yeah.
Beep.
So question 12 is asking if it's a good assumption for them to say that their sample mean is normally distributed.
Mm.
Yeah, because the sample size is bigger than 30, so I think yeah.
Yeah, so I'd say it's a good assumption since the sample size is large.
Yeah.
Okay. 40, 60.
And is that the law of large numbers?
Yeah, I think so.
I'm pretty sure.
Pretty sure it is, because it says if the sample size is large enough.
Like, yeah.
Yeah, it's
It's
in the
the central limit theorem though, because it says as the large number, as the sample size get larger, it guarantees that the mean will be closer. It will be the data will be distributed normally.
Yeah, Luis is right. It is the central limit theorem. That's what the book. That's what at least the book says. That helps.
Which one's the law of large numbers then?
So it's so we learned that so x the little line over it will follow.
Yeah.
This is what it says. We learned that x with the little line over it will follow a normal distribution if the data are drawn from a normal distribution or if the sample size median is large.
Yeah.
Sample size n is large.
And then what does the central limit theorem say? Is that the central limit theorem?
That was the central limit theorem.
Oh, what does the law of large numbers say?
Hold on.
The large number, I think it guarantees us the what's the name?
Oh, the mean will get closer and closer
the
to the
standard
average of.
the standard deviation gets smaller.
Yeah.
The mean
Oh,
gets
okay.
close to the population mean, something like that.
Yeah, so the law of large numbers is
I
that
gotcha.
as the sample size grows, its mean will get closer and closer to the average of the whole population.
Yeah, that makes sense. Okay, I got it now.
Sweet. 14.
Okay, which of these is a test statistic?
Which of these is a test statistic? Z.
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 Yeah. Z. That's what the book says.
That's cool with me. Oh yeah, this says give the test statistic and its value, so
Yeah.
for sure Z is a test statistic.
So we cannot argue.
Yeah. Okay, so the historical mean of sales receipts at a grocery store is $150 with a standard deviation. Well, that's a big standard deviation.
Of course, she gets the test.
Okay, what is the z-score associated with this test? So we're going to take 150, wait, other way. 144 minus 150,
Yeah.
Yep.
but then we have to divide it by, oh,
The sample standard deviation.
yeah, well, we have to divide it by 40 and then divide it by the square root of 36.
Yep.
Oh, so it's going to be negative 6 divided by 6. Oh, wait, is it? No, I did that wrong. Or did I?
Let's see.
Yeah, I did that wrong. Okay. So I got negative 0.9.
Yeah. 0.9.
Someone got the same answer as me, so that's good.
Sorry, I'm just looking at it as well.
Oh, good. Then it asks for the p-value associated with the z-score. Okay, so this is just going to be one-tailed, so it's going to be a 0.184. Does that look right?
I think so.
So you got negative 0.9?
Yeah.
Yeah.
Yeah, that's what I'm getting, but I'm just I don't know. I'm just not 100% right now.
Yeah, I did the 36 square root. Wait, sorry. Square root of 36 is 6, so you do 40 divided by 6
Yep.
to get then I put that in the memory. Then you have to do 144 minus 150, which will give you negative 6. And you'll divide it by your standard deviation.
Yeah. Yeah, I'm pretty sure that's it.
Cool. And then
But
we plugged it in, and we did just the left tail because all it's asking for is less than 150. And then what inference would you make about the null hypothesis for this problem?
wait, so what did you guys get for 16 then?
Oh, sorry, 0.184.
184. Okay.
Yeah, therefore.
Sweet.
So our level of significance is 0.05. So if you look at those things here. So our p-value is still greater than the level of significance, right?
Yeah.
So
Yeah.
we can't reject it yet. So I think we fail to reject still.
Yeah.
Okay, and then 18 is asking for what our conclusion is. I think it's this one that I selected. Because I think the only thing we can conclude is that we don't know if the true population mean is less than 150.
Yeah.
Yeah.
Cool.
Yeah.
Yeah, sure.
I was just looking at this one. These are always fun. So this one's talking about the two errors. Which one involves rejecting the null hypothesis when the null hypothesis is true? So if the null hypothesis is true, then you reject it right here. Type 1 error.
Yeah, and it's type 1.
Type I. Ooh.
So 19 is type 1.
Yep.
Yeah.
So for 20, he's going to end up having a harder time making his alternate hypothesis. But yeah. Okay. So this says if the A value is very small, the probability of committing a type 2 error will be large.
Large. Mm.
Okay.
So I think the type 2 error will increase.
I'm
Yeah.
down with that.
And then this asks what the probability of committing a type 1 error is if you have a 0.05. Huh.
Point zero five. Point zero zero. Point zero. Yeah.
Okay, so the level of significance is the probability of committing a type 1 error. So this is like a, what, a 2% chance?
Mhm.
Wait, what's 5 divided by 100? 20?
Yeah.
Yeah.
So it's like 20% chance, but the probability of that.
It's a little less than 20, but yeah.
Yeah.
What do we put for this one? Isn't that all it is? It's like the same number?
I think so.
Because it says that that's what it is.
Yeah.
Then compute the probability of the computer. Yeah.
I'm guessing.
Seems right to me. I mean, luckily it's just the last one, and so
Yeah. Should we submit it? See how we did?
Yeah.
yeah, because that seems right.
That's the only thing I could think of. They don't give like equations for solving it. We did it!
Yep. Sweet.
Well, I'm glad you guys read the book good. Or found the stuff in the book good.
Yeah.
I just forgot all this. I have like the preparation and everything, but I was like, oh man.
I just kept the book open the whole time.
Yeah.
Yeah.
Cool.
Me too.
Do you guys have questions? Does anyone have questions?
I'm good.
Yeah.
So far, so good?
I'm thinking about the project work.
Sorry, what was that?
I'm thinking about the project work.
Oh, the project?
That's yes.
What is our project?
So yeah, when you go to the course folder, the last folder, final project. So I think we should have time to go through it. Then our next meeting will discuss about the first one,
Okay.
the design.
Yeah,
Yeah.
that was a good idea. So that way we know what we're talking about.
Yeah. Yeah. We will be submitting this thing of I think it's the ninth week, I think so.
Yeah, it's
Yeah, the first one says due end of week 9.
Yeah. Yeah.
Okay, so do we want to like read through it all or just like?
Yeah, we will read it individually next week. We'll discuss it.
then we'll just come back on Monday and figure out what we want to do.
Yeah.
Sounds good. So are we meeting Monday or Tuesday next week?
Oh, yeah.
Yeah, Monday or Tuesday, you know.
Tuesday will work better for me.
Let's
Tuesday
just
at
do Tuesday.
Tuesday at
Tuesday?
2?
Yeah. Tuesday at 2.
That's cool with me. I can keep doing that.
Sounds good.
Okay, me too.
Okay, I can stop this thing now and get it